Hello everyone. So in today's video, let's try to understand all about indexing. Well, when I say all about indexing, we'll not go very deep into indexing, but we'll try to understand things on a high level. So let's see. We have 4 questions that we'll answer in this video. The first one is, what exactly is database indexing? There we'll see a wonderful analogy to understand what indexing is. The second thing that we learn is, how do we even create indexes? We'll know about the mechanisms and the procedure, how indexes work and how it is created. And the third one is, does the DB automatically add indexes? We'll answer that in our third part. And finally, we'll look at, if indexing is so awesome, let's just use it everywhere. But there's a catch there. We do not use indexing everywhere. We do not overuse it. So all of these topics will be covered in this video. Now let's move on to the first part, which is, what exactly is database indexing? Well, if you ask me honestly, I'll answer that it's very similar to the index page in a book. So consider a scenario. Imagine you're searching for a specific recipe in this cookbook. Let's say you are searching for palak paneer and it's on page number 253. Now, you'll be crazy if you just flip through those pages and go on to page number 253 to find out the recipe for palak paneer. You'll be easily frustrated if you have to use this kind of mechanism to find recipes. So what do you do instead? We know that there is something called as index page in a book. Like for example, if you look at this index page, we have palak paneer at 253, sushi at 351 and more recipes. So it's very easy to find out recipes like this using the index page. By using indexes, we can find these recipes instantly. So that is what we have written here. It helps you jump directly to the page you need and it's instant. Now, database indexes are very similar. The DB indexing helps in locating specific rows instead of scanning every record. Now, what does that mean? Now, if you look at this table, users table here, we have different IDs, username and emails. Now, let's say if I want to find out where Adam is located, I can see it here. But using indexing, we can access this whole row almost instantly. That is the power of indexing. So, database indexing works very similar to our index page in a book. It allows database to quickly locate specific rows instead of scanning every record through this table. Now, when I talk about it that way, it feels like a magic. So how does that magic work? Let's look at that next. Now, let's look at, how do we create indexes, or how does that magic work? So here we have 4 things to discuss. The first one is creation of indexes and how are indexes created. So let's take example of our users table here. We have 3 rows, first with ID 1, ID 2 and ID 3. Now, an index is created on specific columns of a table. This is very important to understand. It's on the column side. So let's say I have an index on username. So what it does, it adds a shortcut based on the username. Now, what does that shortcut look like? Now, let's look at how indexes are stored. So, let's say for Partha, we have saved the username as Partha, and then we are also storing a pointer to row 1, because at row 1 we have Partha. Similarly, we also save Adam and then a pointer to row 2. Similarly for VJ and pointer to row 3. So this is kind of a mapping. So next time somebody comes up and asks, where is VJ? So it will go ahead and just give us the pointer to row 3. That is this one. And our job is done. That is why indexing is so fast, because we do not need to go through each and every row. We just look at this table here and then find the row using this mapping. Now, something to note here, we have made indexing based on username, but somebody else can have an index based on email too. Next, let's move on to the structure. What does structure mean? It means, how are these indexes stored? Well, indexes are commonly implemented using data structures like B trees, which is shown here, and also using hash tables, which is very similar to what we saw earlier here. Now, in a B tree, data is stored in a hierarchical structure, and it's a sorted structure as well. It allows for efficient searching, insertion and deletion, all of the common operations. We'll not go very deep into this B tree, but understand this as a structure which gives us the power to store our data in a sorted manner. So in summary, we have B trees and hash tables in which we store these indexes. Now let's move on to the third part, which is query optimization. Here we have a sample query. It's select star from users where username equals Partha. Very straightforward, right? So in this case, the database first checks for an index on the username. It looks at this part and tries to check if there is an index based on username. Well, in this case, there is. We have a table where we have a mapping between username and a pointer. So in this case, we are looking at username equals Partha. It will look at this and then point us towards row number 1 here, and it will return that. Very quick, right? It didn't need to go through all the entries in this users table to find out our answers. Now let's move on to the sorted searches part. How does indexes help with that? Here I have added one more column, let's say age, and we have to have the index based on age. Now what do we do here? We'll organize this age in a B tree, which looks very similar to this. We'll have a B tree here, and as we saw, B tree is nothing, a hierarchical structure which has some ordering. Now as you can see, all of the elements less than 20 are placed here. All of the elements greater than 40 are arranged here and in between here. So now let's say somebody comes up and asks us the query, find me all those rows where age is greater than 30 and age is less than 40. That is, find me all those rows where age is between 30 and 40. For those kind of queries, this organization of data is very helpful. That is, whenever you need to do efficient range querying, you should think about having B tree. And whenever you need to find exact matches, you should go with hash table. Now let's move on to yet another question. Does the database automatically add indexes? Well, the answer is yes. So most databases automatically creates an index on primary key columns. That is called as primary key index. So taking our example of users table here, let's say we have our primary key as username. So our database will automatically create an index on this username. But there is another kind of indexing that could be done, which is manual indexing. So users have the option to add indexes manually based on query patterns. Now what does that mean? Let's say we have a common query on emails. So we'll focus on that, and based on that we'll create index on email. But that needs to be done manually. And how do we do so? Well, we can do so by this. Create index IDX name on user's username. Now this is very confusing. What does this mean? We are trying to create an index of the name index IDX underscore name on the users table and on the column username. So I want to create an index on this username here, and I'm calling it IDX underscore name. This will create an index on username column. Now indexing looks very awesome. Let's try to use it everywhere. It's a new concept for me, so let's use it everywhere. Let's have indexing on every column, every kind of query pattern. But wait, we shouldn't be doing that. There are certain downsides of indexing. So let's look into that. The first one is pretty obvious. We have a storage overhead. As we saw, we need to store a hash table or a B tree, something like this. So each index takes up additional disk space. So there is some storage overhead. There is yet another problem with indexing, which is write performance. So every insert, update, or delete operation on this requires updating indexes, which can be slow. We have to update for every insert, delete operation. We have to make changes to this, and that too whenever we are writing. So that is why it said when we have a write heavy application, we should conserve our energy and have only specific indexes. But how do we choose those indexes? That's where query patterns come into picture. You should look at all the common query patterns that you see, and based on that you should have the indexes. So these are my final thoughts. Indexes are wonderful for read heavy operations, but we shouldn't be overusing it. We should think about all the possible query patterns and only create indexes for those. Well, that's it for this video. I'm hoping that you learned something about indexing from this video, and you can use these concepts in answering your interview questions. See you in the next one.